Alright, so let's take a gander. I'm going to run this in the simulator. And what he basically is doing is leveraging something called LibGME. LibGME is a game music library that basically ties in multiple consoles into one single library, can play music from various formats. So I'm custom implementing or including LibGME into this ReactNative custom project, and the UI is driven by React.js, driving the front end part using the ReactNative kit. And the fun bit is when you say, okay, I want to be able to let's say play a song or something, and today this is using a singleton right now. So this I have an interface class which is here, and he basically is an interface to this ReactGME player. Now he's the guy that actually implements, if I go to his header file, LibGME, and leverages also something called Audio Toolbox to cue the audio buffering. And there's quite a bit of code here, but the cool stuff is basically after we've configured the audio oh boy, what do they call him? The data format, basically. Basic description, that's what they call him, I forget. After we've looped our buffers and queued up the initial bufferings, basically, or the initial pass of bufferings, there's something called a callback that needs to happen. So in the first phase, this actually will leverage GME to fill up the audio buffers. Okay, so we have a number of buffers. I think it's like 12 or something. We'll update that guy because he needs a little bit more time to process stuff. I'm noticing a little bit of clipping in OS 10. Anyway, so there we have it. We have the audio data buffers being filled in and so on. And then we have to queue them up. And then this pattern actually is implemented in the callback as well. If I go back to the, where are we? Audio callback method, I think I scrolled right by him. He does the same thing. So when the audio callback method is executed through the audio queuing system, this is kind of iOS's way of doing things. We do the same thing. We actually ask GME to give us the audio data for the next round, and then iOS or OS 10 basically takes this buffer data and streams it to the sound card, and then basically continuously calls the callback in a double cyclic buffer type of thing. So we're going to see an NS log come out from the callback saying filling buffer, the ID number, and so on. And then this mbuffer user data is something I actually configured. I'm casting into an int because I wanted to get an ID on this guy, and that basically is set up here whenever we do our first round of buffer filling. So I'm going to go ahead and run this guy. And what he does is shows us in later. This actually works very well on my phone as well. iOS 8, iPhone 6, and I press. Initially, what he does is he leverages the ReactGME FS Explorer class and allows me to browse directory structures. So like this stuff here actually is physically deployed to the device, and I can expand, let's say, this guy, and then if I were to go back to here, we'd see the files represented and so on. So I'm going to go ahead and head back. Let me lower the volume here because I'm going to need to make sure I don't have an echo. So I only have 2 games loaded for SNES right now, only because those files are a lot bigger. But I'm going to go ahead and play some NES tracks. And right now all he does is play track 0. So the way the sound formats work, NSF is a Nintendo sound format that basically has all of the game musics, or excuse me, all the game songs in one file, and it's managed by a header, and all the offsets are implemented by a header. whereas with SNES music today, each individual song has its own physical file on the file system. I believe there are ways to kind of put these together using a zip file or something. I just haven't implemented that yet. So testing NES, if I go to something like M, and this is so smooth, I love ReactNative. Mega Man 2, we can see that the buffer is being filled, and we can hear the audio being played. And then to try a different track, I just tap on it, and then that basically loads a new track. And I can just continue down this path. There's no stop button yet, so to stop this I basically have to press Command R at refresh. And then to test a different track, a different game system, I can just type in or tap the SNES games. And you know, if you're used to using something like Pilot Wings, you know, you got this sound or this song or this song, and there you have it. The next step is to actually take this this app and implement something called Easy Audio Plot. So Easy Audio Plot, if I were to pull that guy up, and let's pull up my implementation. So this is going to be an entirely different project, and what he does is basically, this was a proving ground to see if I could, one, implement LibGME in iOS, and that was no problem. And then the next bit was to take Easy Audio Plot and make that into a library, and that's actually implemented over here. So if I hit Command R, this actually will load one song, and then will render the audio data using the plotter's update buffer method after I have taken the raw uint32 data and cast it to Essence16, and then converted that to floats, and then streaming it for the left and right channel. So let me go ahead and hit Command R here, and we should see the app launch. Again, this is just a prototype, making sure that we can actually get this working. So I plan on including these implementations of the audio plotter in ReactNative, and they'll have their own custom components, and from there, you know, kind of sky's the limit. So yeah, thanks for watching. This has been a lot of fun. I am absolutely in love with ReactNative.